Hi grade 8s. In our previous video, we talked about density as a property of matter and went over the formula. So today we're going to pick up where we left off and talk about how to calculate density. So just to remind you, here's the formula for calculating density that I showed you last time. Density equals mass over volume. Now, if we want to write it as a shorter form using just the letters for the variables, we could also write it as D equals M over V. So here's a sample problem of the type that I might ask you to calculate for me. Mrs. Williams has been spending a lot of time at home recently and has started to do some baking. To entertain herself, she has started calculating the density of some of her baking ingredients because, after all, who doesn't love to do a few density calculations? The block of unsalted butter has a volume of 442 cubic centimeters and a mass of 450 grams. What is the density of the butter? So I'm going to start by pulling up the question again. I've shortened it a little bit to make the information stand out a bit more, to make it clearer. The block of unsalted butter has a volume of 442 cubic centimeters and a mass of 450 grams. What is the density of the butter? Now right away, I can see that I've been given all the information right in the question that I'm going to need to solve for density. And a really good tip sometimes when you're tackling a word problem like this is to circle or highlight the information right in the question that you know you're going to need. So in this case, I've been told that my volume is 442 cubic centimeters, and I've been told that my mass is 450 grams. Now, once I've highlighted that, I can get right on with solving my problem. Whenever you do a question like this for me, I'm going to ask that you start by stating what you're given in the question. So it would look like this. From the question, I know that I have a mass of 450 grams, a volume of 442 cubic centimeters, but I don't know what my density is. So I'm telling you right there, when I write this as part of my answer, that these are the variables I know, but I don't know density. Your next step is to state the formula and then solve it. So here I know that density is equal to mass over volume. I substitute in the values from my question, so that turns into 450 divided by 442. And if I do the calculation, I end up with this really long number here, 1.018099545. In our cases, whenever you get a really long number like that, you can always just shorten it or round it to 2 decimal places. And then your final step whenever you're doing a question for me is to write a therefore statement. In this case, you can write the full word therefore, or you can use these 3 little dots. They mean the same thing as therefore. So therefore, the density of the butter is 1 200 grams per cubic centimeter. Okay, so the first problem I gave you was pretty straightforward. I told you exactly what the mass and the volume of the butter was right in the question, and you just had to plug the numbers in and calculate the density. But these questions can be a bit trickier. Take this for example. Mrs. Williams moved on to corn syrup. She found that 50 milliliters of corn syrup had a density of 1 4,600 grams per milliliter. How much mass did the corn syrup have? Now in this case, I don't directly tell you that the volume of the corn syrup is 50 milliliters. You actually have to figure that out by seeing the unit of measurement is milliliters. I also, in this case, have told you the density of the corn syrup. I haven't given you the mass, and that's what you have to calculate. So again, I'm just going to pull the question up right at the top of the page so it's right in front of us, and we'll walk through the solution. So again, I'm going to start by highlighting the information that I've been given in the question, just so it's right in front of me. So I know that I've been given 50 milliliters of corn syrup, and because they gave it to me in milliliters, I can assume right away that that's my volume. I've also been told that I have a density of 1 and 4600 grams per milliliter. And what I'm being asked to find out here is how much mass did the corn syrup have. So let's walk through how you would do that. This is actually going to be our first option of how to address a question like this. So I'll walk you through two ways. You can figure out which way works for you and just stick with that. So first off, we're going to start exactly the way we did before. We're going to state what we were given in the question. So in this case, I was told that my volume was 50 milliliters and my density was 1 and 4600 gram per milliliter, and I don't know my mass. So that's why I have an M with a question mark there. Next, I'm going to state my formula, and that's where we have a little bit of a problem, because our typical formula that we would use is density equals mass over volume, but in this case, we do know our density and we don't know our mass. So our first option of how to address this, if you're someone who likes to rearrange formulae, then you can just rearrange it and say that mass equals density times volume. So if density equals mass over volume, then mass has to equal density times volume. Once you've rearranged the formula, you can simply plug in the values from your question and get on with solving it. So for density, I can plug in my 1 and 46 grams per milliliter, and for volume, I can plug in my 50 milliliters. So mass would then equal 1 and 4600 times 50, which would equal 73 grams. As usual, I'm going to end up my question with a therefore statement. Therefore, the mass of the syrup was 73 grams. Now, one thing I do want you to notice here is that my unit of measurement has changed from the last question. Because I'm now calculating mass and I'm not calculating density, I have to use the unit of measurement for mass. So I'm going to say that my mass is 73 grams. So in a question like this, double check at the end that you've used the unit of measurement in your answer that matches the property that you're calculating. So here's the same question. We're just going to handle it a slightly different way. And being 100% honest, this is not a huge difference, but some people do prefer one way, some people prefer another way, and I thought I would show you both and let you choose. So in this case, I'm going to start out exactly the same way as before. I'm going to state what I was given in the question. So I state my density, I state my volume, and I use the question mark to show that I don't know what my mass is. Then I'm going to state my formula and substitute in the values of my variables that I know and work out what mass is. The only difference is, in this case, when I state my formula, I'm not going to bother rearranging it. If you're anything like me, I don't have a great memory. If I can remember one formula, I'm doing well. So I don't want to have to think about all the different variations for the 3 different variables. So I just take the same formula, density equals mass over volume, and I just substitute in the values that I know. So I put in 1 and 4600 grams per milliliter for my density, and I put in 50 for my volume. And then it's just a question of using math, of working it through step by step, and I'm still going to come up with exactly the same answer. Mass equals 73 grams. then we're totally back to the normal method. I would end up with a therefore statement. Therefore, the mass of the syrup was 73 grams. So now, here's another twist. Let's look at the following sample problem. Getting bored with baking supplies, Mrs. Williams looks for other objects to use in her density calculations. In her pencil case, she finds an eraser. Dropping the eraser in a beaker of water, she finds that it displaces 8 milliliters of water. It also has 13 grams of mass. What is the density of the eraser? Now, if you looked at this question really quickly, you might think that I forgot to tell you the volume of the eraser. But what I did tell you was that the eraser displaces 8 milliliters of water. Because we know about displacement, we understand that this means that the eraser itself has a volume of 8 milliliters. Now, another thing that might confuse you is the fact that all of a sudden we're using the unit of measurement of milliliters when we're talking about a solid eraser. But there's a really simple fact that we know that will help us solve this. It turns out that 1 milliliter takes up the same amount of space as 1 cubic centimeter. So if our eraser has a volume of 8 milliliters, we can also say that it has a volume of 8 cubic centimeters. So same as before, I'm going to start out with my question at the top just so we can keep all the important information in mind. And just like I did before, I'm going to highlight the important information in the question. So in this case, I know that my eraser displaces 8 milliliters of water, and I know that it has 13 grams of mass, and I need to find the density. So just like before, I'm going to follow the same steps. I'm going to start by stating what I'm given in the question. So there I've said that I know my mass is 13 grams. I know my volume of the eraser because it displaces 8 milliliters of water. My volume must be 8 milliliters as well for my eraser. The only change I'm going to make is I know that my eraser is solid. So if it has a volume of 8 milliliters, I'm just going to express it as 8 cubic centimeters. And I can do that because I know that 1 milliliter is the same as 1 cubic centimeter. And then I'm just going to show you that my density is what I don't know, and so that's why I'm giving a question mark there. My next step, as usual, I'm just going to state my formula. Density equals mass over volume equals 13 divided by 8. So I'm just going to put the values for my variables in there, and then I'm going to calculate, and I come up with an answer rounded to 2 decimal places. Don't forget that one. That my density is 1 63/100 grams per cubic centimeter. Then, as usual, I'm going to finish up with a therefore statement. Therefore, the eraser has a density of 1 63/100 grams per cubic centimeter. So in this slideshow, I've tried to give you an overview of different types of density problems that I could give you in the classroom and ask you to solve. We're going to follow this up now with a worksheet for you to do some practice for yourself. So have fun!
Thank you.